Welcome back everyone, my name is Pedram and this is where we do advanced time series analysis, deep forecasting. Alright, we've reached the final stretch of this deep forecasting course together. It's been amazing walking through these 8 modules with you all, and we started from classical models and then we went to the machine learning and then deep learning. And now we are wrapping up with NeuralProphet. So in the previous theory lectures, I covered the theory of Facebook Prophet. We explored the paper together, and then we talked about the NeuralProphet theory in the previous video. And now in this one, we're going to see how we can implement NeuralProphet in Python. So I really hope during this journey with me, you were able to pick up at least 1 or 2 useful tools that you can apply in your own work, right? So this course also set the stage for what's next. You know, a new series I'll be putting together over the summer, and it's going to be called Deep Quantitative Trading. We've seen how some of these certain models can outperform a naive forecaster. Especially today, you're going to see that our NeuralProphet is able to outbid our naive forecaster when it comes to stock price. But the real question is, what do we do with that, right? How do we turn predictive signals into actual trading strategies? So that's a different game entirely, and that's exactly what the next course will explore. So I will record a separate video soon with details on that, but for now, let's dive into the final hands-on video and see NeuralProphet in action. So without further ado, let's see where you can find the materials, and let's open the notebooks. Okay, so I'm going to have the PDF open here and at the same time show you where you can find the materials, because during the tutorial we might need to go back and forth between the slides and basically talk about the detailed components of the NeuralProphet. So basically this is what I'm talking about, different components of NeuralProphet. So this is what we covered in the previous video. So if you haven't watched the theory, or if you think that you need to have you don't have the theoretical background, I highly encourage you to watch that one first and then come back to this video. All right, so here's my GitHub repository. Go to the deep forecasting course, lectures and codes, and then the very last module, Prophet and NeuralProphet. Actually, I have this miscellaneous one also open in the other tab, because today I'm going to cover 2 notebooks. One is one is going to be our NeuralProphet, so module 8 NeuralProphet, the notebook, and the other one is, if you go to the miscellaneous folder, there's a stock market folder, and there is one file called predicting stock price using Prophet and NeuralProphet. So we're going to compare the performance of these models on Apple's stock price for the past, I believe, is it 5 years? Well, we will double check. But we will see among the econometrics versus machine learning versus deep learning, and now this Prophet and NeuralProphet, which one is performing better. Yeah, so this is going to be on stock daily prices. Okay, so now let's go back to the main notebook for this tutorial that I put together, and it's called module 8 _ NeuralProphet. So I'm gonna go ahead and have it open, and you can run it in Google Colab or on your local computer if you want. So here today I'm gonna run it on my local computer because it's more straightforward, and I just want to have a separate environment for Prophet and NeuralProphet on my local machines. But the choice is up to you. You can run it on Google Colab as well. So if you click on this, you should navigate you to the Google Colab. You need to connect it. And of course, you need to go ahead and install the packages first. So what we have in the documentation here is that we can access to the forecasting at a scale paper. So this is the Facebook Prophet paper. We have the NeuralProphet paper and the documentation of Prophet, as well as the documentation of NeuralProphet. So just like the previous video that I talked about the documentation of Prophet, so the documentation of NeuralProphet is just amazing, just like the Facebook Prophet one. And it's pretty straightforward, and you can self-study it yourself. I will walk you through the points that I think it's useful for you to know, but again, I will leave it up to you to just explore the entire of this documentation at your own pace. But as we talked about, NeuralProphet is a combination of Facebook Prophet and ARNet model. So this is a hybrid model which basically combined whatever we got from the econometric side of the course with the deep learning, the neural network, put it together, make a nice model, call it NeuralProphet. And as you remember from the theory lecture, it's going to outperform the Facebook Prophet in all the real world benchmarks as well as the synthetic data sets. All right, so let's start with the quick start, but at a very high level, you can see that the setup is pretty straightforward. Once you install the package, you're gonna create an object. This is your model, and then you fit it to the data set. You can make predictions. So this is going to be in-sample prediction. We're gonna change this to a future data set because that's what we wanna do. We wanna forecast into the future. But again, as you can see, with just a couple of lines of code, you can get access to the forecast, the plots, the component plots, and everything. So this is pretty straightforward pipeline, and I really like the documentation as well. So you can go ahead and click on this quick start to help you with the installation. You can install it through both conda and pip. So we can do pip install NeuralProphet, or you can do also, I think there was a conda as well, but anyways, so the point is that if you want to run it in a Jupyter notebook, I absolutely encourage you to install the live version. So just do pip install NeuralProphet live. Otherwise, you're going to have really hard time visualizing the plots, or you're going to get a bunch of errors. So this is really important. So again, if you want to run it on Google Colab or VS Code through Jupyter Notebook, this is what we're going to do. I absolutely want you to install NeuralProphet in brackets live. Okay, and it's a good idea to create your own, if you're running it locally, create your own environment, call it Prophet or whatever, and install both packages. You can do install Prophet and at the same time NeuralProphet, and this is what I have done on my local computer. So again, this is the file, neuralprophet.ipy notebook. And I can go ahead and select the kernel, which is, I call it Prophet. And now we can just simply check that if the packages are ready to be used. Okay, I'm gonna, from NeuralProphet, I'm gonna import NeuralProphet, and with, okay, no complaint here. And yeah, this environment is up and running on my local computer, but hopefully you can as well run it either locally or through Google Colab. Okay, so in this notebook, I will walk you through everything you need to know in terms of implementation of NeuralProphet using Airline passenger data. So this is one of those data sets that, let me actually open the PDF, that the authors also tested the model against it. So if you remember from our theory lecture, so yeah, this one. One of the data sets that the author tested the model against was Airline passenger. So we're going to look into that one simply because this is one of the most well-behaved time series with a nice trend and seasonality component. And we want to see how our model performs. And basically, we want to compare with other models that we have done in the entire course, right? So, and then at the same time, I'm going to walk you through to the other side, to the which we are predicting stock prices. So I think this one. So we're going to look into this notebook as well. So this is one of the least well-behaved time series, right? So we're going to see on both extremes, how does Prophet and NeuralProphet perform compared to other econometrics and machine learning and deep learning models. All right, I think this is the setup. And the rest of the video is just me walking you through this documentation, the tutorials, and everything you can find here, as well as basically how we can implement this in Python. All right, so let's start with the tutorials, and then we're gonna go to my own custom notebooks as well. Okay, so starting with the basics. And so for this one, I think we're gonna go ahead and work with the energy price data in the past 4 years. This is a daily data in Spain. And as you can see, we can go ahead and load the data set. This is how it's gonna look like. And hopefully at this time, your eyes are trained to figure out what kind of model do we need for this? Is this time series well behaved or not? Do we need to think about complex deep learning model at this point? Or how do you think that what is the best approach to just move forward, right? And then we're gonna go ahead and set up the model. So again, from NeuralProphet, we're gonna import NeuralProphet, You don't need to disable the logging messages, because actually you're going to see that in the notebook, we need to see those messages at least once, because in those messages, it's going to tell you what is the, for example, if you're doing the if you're adding the AR component with neural networks, you want to see what is the batch size, what is, for example, how many epochs we're using, and if the seasonality is on or off. So things like that. I think you don't need to just set the errors to be disabled. So don't do this part. And yeah, we're going to create an object, NeuralProphet, and we're going to fit the model, right? So the model has been trained. And for the backend plotting, you can use Plotly static. And actually, I think if you install the live version, you don't need to do the static. You can just go ahead and set the plotting backend to Plotly or Matplotlib. That's going to do the job. You don't need to go with the static version. And once the model has been trained, you can go ahead and basically make some predictions, right? So in order to make the prediction, this part is pretty much the same as Facebook Prophet. You have to create this future data set first, and there's a function for that. So you need to create this data frame by calling off of that object, which the model has been trained inside it. You say make future data frame, you pass the original one, and you want to see if you want to show the historical data, if you want to include that historical data in the future data set as well or not. We would say yes, because we want to visualize it. So this is the historical data, this is the future, and obviously the number of periods. So here we're going to look into 1 year into the future, so 365 days. And yeah, after that, you can go ahead and make predictions on that future data frame, okay? So, and if you plot it, this is how it's going to look like. The black ones are actuals and the blue ones are predictions. Obviously, the model is off at some certain times. So then we're going to see if we can make it better. So what are the solutions, how we can tune, how we can play with the hyperparameters, and etc. But this is a very high level tutorial. It's me walking you through all these things very quickly. Okay, then after the model has been trained and you made the forecast, you can go ahead and plot the components, right? If you use the plot underscore parameters, by default, it's going to show you everything. So here, because we have trend and seasonality components, it's going to plot that for you. So remember, in the theory lecture, we said that by default, the seasonality for weekly, monthly, and daily is on. This data set, because it's a daily granularity, the daily seasonality doesn't make any sense. So that's why we're going to see only yearly and weekly seasonality, right? So yeah, this is pretty much it. So for example, if you end up adding these components, you will get to your predictions, right? Okay, so then, yeah, that was a high level of the basics of NeuralProphet. And as you can see, this is pretty straightforward. Now we can go to the details, right? So we can talk about trends, seasonality, autoregression, lag regressors, future regressors, events and holidays. And finally, we're going to talk about uncertainty quantifications as well. So for the trend, going back to the slides, so actually let me make it full screen. So this is the trend component, right? And we know that you have to specify how many change points you have. By default, NeuralProphet is using 10 change points. Obviously, you can change it. Basically, for each change, for each of those regions, you know, within the change points, you're going to have a slope and an offset parameter. As we said in the theory lecture, the offset parameter makes sure that there's continuity, so you can connect these trend lines back to back in a continuous fashion. So that's what the offsetting parameter is doing, and the growth rate, of course, is going to be estimated for within each change point, right? And that's how we can set it up, right? So the model, we're not going to go to the defaults, use the default setting. We're going to specify things from now on. So right now, we're going to start with the very basic with 0 change points. So this is a model with 0 change points. So it's going to fit everything into one line. And that's what you're seeing, right? Everything is just fit into one line. There's going to be one slope, no change points, and etc. And we're going to turn off the seasonalities because we want to look at the model that's purely having the trend component, right? So let me go back and tell you what's going on here. So the default model in NeuralProphet, there is no AR component. That one is off. And obviously, in this case, we're not specifying lag values or future values. And we are not defining even any events or holidays. So it's going to be only trend and seasonality. And here we are specifically switching off seasonality by doing yearly, weekly, and daily seasonality to be false. And we're also saying that there's going to be just one trend line with zero change point. So this is what your model is doing. Again, this is not shuttle science. You're going to look into your through your data and do a simple trend line, and that's what the model is predicting. And now if I go ahead and look at the component, there's going to be one component, which is trend. Obviously, that doesn't make any sense to do it for this data set. We're going to go ahead and change the number of change points to the default, which is 10. And now you're going to see, okay, this is going to be a piecewise linear kind of regression kind of things, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So now it's broken down into 10 lines, right? Without considering any kind of seasonality. All right, so that was the trend component. Now let's look into the seasonality component. Okay, so for the seasonality, if you remember from the slides, we can add the seasonality both in an additive or multiplicative way. And then by default, the daily, weekly, and yearly are on depending on your data frequency. So in this data set, actually, it doesn't make any sense to have daily, but let's just explore how things look like. So we're going to turn off that trend component. It's not by turning off, I mean, have only just zero change point. Everything is going to be in one line. And so of course, there's going to be a trend, but no change points. And then let's look into only yearly seasonality. So this is how we define a model. We can fit it and then make prediction in the train set. So this is all these predictions that we're doing in this tutorial is just in sample predictions. In the notebook later, we're going to see that we're going to change this to future data frame and things are going to look different. Okay, so, and this is how it's going to look like. This blue line are the predictions, which is a combination of trend and yearly seasonality, right? So if I plot the components, you will see that there's a trend component and yearly seasonality. And then if you add up these two lines, you will, plus some noise, you will get these predictions here. Well, just adding these two lines are going to give you the predictions. And of course, the real data comes with noise, right? So for example, here, January 2015, day 1, if it is 56-ish, the temperature here, oh, sorry, this is a price, energy price, right? If it is 56, then it seems that 50, what is the scale? Maybe 52 of it is coming from trend, and then 3-4 of it is coming from seasonality, right? A yearly seasonality. And we can also plot those parameters separately to just, again, this is the yearly seasonality. And then within a year, you want to see how it looks like. So this is the same thing within a year. If I go from January 2015 to January 16, if I look at this part, this is pretty much the same as this. Okay. And it makes sense for this data set, right? It seems that during spring, I don't know, this is Spain data. I'm not quite familiar with the weather there, but this is my assumption that probably during spring, there's going to be less consumption. There's no AC, neither heater. And then as we go to the summer, it picks up. And then to the winter, it also gets to maximum, right? So these are the energy prices. And that should be pretty straightforward. All right, then next we can go ahead and switch on all the seasonalities, weekly, yearly, and daily. And yeah, we'll see how the predictions are going to look like now. So the blue ones it's going to be, of course, going more up and down because we're adding weekly seasonalities as well. And this is how yearly and weekly is going to look like. And of course, daily seasonality, this doesn't make any sense. This is just because your data is daily. And of course, we don't have any intraday differences, right? If your data set is daily. And we can look at the components. Again, the same story, seasonality, yearly, this makes sense. Weekly, so maybe Sunday, Saturdays, there's less consumption during the weekday, the price is going to be higher. And again, this daily is going to be pure noise. So just ignore this one because if your frequency of the data is daily, just don't look at this one. And so that was, if you want to go with daily, weekly, yearly in an additive or multiplicative. If you want to do more sophisticated, more custom seasonalities, of course there's a tutorial for that too. Let me actually show it to you where you can find it. If you go to the feature guides and then go to multiplicative seasonality, so here, or conditional seasonality, so this is where you can use those for your series. And then this one, the multiplicative is easy, you just need to turn it on. Seasonality type, instead of additive, it's multiplicative. But conditional seasonality, this is more exciting. I encourage you to just take a look at that one and check it out. Yeah, so this one was the seasonality. Let's look into the autoregression next. For the autoregression, if you go back to the slides, you will see that we could add these lag terms in a linear way or nonlinear way. We can put it in a neural network. Just be aware when you do NeuralProphet, open close parenthesis, by default, this autoregression component is basically turned off. So we have to specify it. So let's go back to the tutorial. So here, as you can see, we're going to work with the model that there is 10 change points. The seasonalities are all on. And then, so this is how it's going to look like. And as you can see, this is the previous one that we captured. Even if you're adding 10 change points and with the seasonalities, the model is doing a very, very bad job here in these peaks, right? And then we want to see what are we missing. So let's go ahead and plot the residuals. So if you go ahead and calculate y minus y hat, and basically plot the residuals, this is what we see, right? So this is pretty straightforward. If I look at the black dots minus the blue ones, so this is what we have. And so if you remember at the beginning of the course, we said a good time series model is a model that when you look at the residuals, nothing is left there, right? The residual looks like a white noise. So does this look like a white noise to you? So obviously not, right? And if you remember from our autoregression module, the ARIMA module, module 4, hopefully our eyes have been trained now. When we look at the process like this is kind of screaming at you. This is an AR1 process. You know, some high values are just just coming after another high values. Some lows are coming just right after or before the lows. So there is a clear autocorrelation here. And this is going to be more clear if I plot the ADF function for the residuals, right? So let's look at the ACF, autocorrelation function for the residuals. And as you can see, this is very strong for basically your autocorrelation number 1. So this one is obviously YT to whatever, the correlation between a variable with itself is going to be 1. So just ignore this one. So from the first one, so this is your lag 1. Lag 1, you're seeing something around 85-ish%, which is very large. So I would say this time series is actually needing an AR component to capture these short-term dependencies. And this is exactly what Facebook Prophet is missing. And hopefully when we use the NeuralProphet, it's going to capture these things. Let's see if that's the case. So we're going to keep the same model with 10 change points for trends and all the seasonalities. Now we're going to add the auto regression component, right? And we're using 10 lags. We don't need to do 10 lags here, but that really depends on how many time steps into the future you want to forecast, right? If you want to do, for example, 20 or 10 time steps into the future, probably you need to use more lags. But if you want to do one step ahead or a couple of steps ahead, so obviously here is going to 1 lag or 2 lag is going to be enough. But again, as I talked about it in the theory lecture, probably you can go with the more lags and you can regularize it back. So let's go ahead and add 10 lags here. And when we don't talk about the layers here, by default, it's going to add linear layers. So just remember, we're going to talk about the hyperparameters later on in the notebook, how we can change them. But if I just add number of lags without specifying the AR layers, by default, it's going to use the linear version of the autoregressions. Okay. So basically, this is going to add yt-1 all the way to yt-10 to the model with a bunch of coefficients. So this is a very simple AR process added to the model. And if we train the model and look at the predictions in the train set, you will see it's going a lot better job compared to what we had here, right? So here, basically the blue line, the forecasts are completely missing the actuals. In this part, the blue ones are catching up to the actuals simply because we're adding this past observation as a predictor, right? So yeah, and if you go ahead and plot the residuals, you're going to see the residuals are going to look a lot more like a white noise. So I think they don't did it in this tutorial, but I have done it in the notebook that I provided. Obviously, you can go ahead and plot the parameters, and these are the auto regression relevance. So the first one is really most of the time, the AR1 is mostly the most important one. This is your naive forecaster, if you remember. Yeah, and then these are the contribution of that auto regressions to the values of the models, right? So values of the time series. So for example, this is going to be our energy prices, and I don't know, maybe in July, so for first observation, whatever this number is, so a big chunk of it is coming from the AR component. All right, so this was the auto regression components. Let's next look into the lag regressors. Okay, for the lag regressors, no, if you remember from the slides, lag regressors are the ones that actually we think that they are exogenous variables that can correlate with your target variable, right? And at the time of forecasting, the future of these regressors is unknown. And we talked about it, why we don't need to have their values into the future. You know, if you have, it's better, but if you don't, that's totally fine, because the NeuralProphet can do multi-output forecasting at the same time. So for example, if you're forecasting for the next, I don't know, 20 days, and you have the historical data for the past 100 days, that's enough. You know, you're going to use that historical data and make a forecast in the next 20 days at the very last day, right? So this is going to basically work even if you don't have the future values into the future. Yeah, let's see how we can do it. In this example, actually for this energy price data set, in that data set, there's another exogenous variable called temperature. And now I think the authors, in order to make sure that the scale match up with the energy prices, they change it to Fahrenheit. So this orange one is temperature. The blue one is our variable of interest, which is energy prices. And this is historical data, right? So we have all the observations in the historical data. And we want to add it to the model. So we're going to go ahead and say, hey, let's stick to our previous model, which has the trends with 10 change points, with seasonalities yearly and weekly on, and the daily is off. And we're adding the auto regression with 10 lag values. And now we're simply adding this lagged regressors. So you have to basically add it to the data frame first. So that's what we have. So our data frame is going to look like this. We have DS, we have Y, and this is going to be our exogenous variable. The lag regressors, future regressors are going to basically show up here in the data frame too. So as long as you have something like this, you can, once you create the object, NeuralProphet, you can simply add it to that object, right? So like this. So here, m.add lag regressor, name of the variable, and you can add 3 lags of that, right? So the temperature is your exogenous variable, and you're going to add 3 lags. Again, this is not the best name that they could think of. We don't need to necessarily call it lag regressors, but anyways, just whatever it is, this is an exogenous variable, and we can add it as an AR component to the model. So this is exactly what we're doing. We're including 3 lags for that exogenous variable, add it to the model, train it, and look at the predictions. So this is how it's going to look like. And now if you plot the components, so this is the aggregated contribution of that temperature with all those 3 lags to the forecast for the energy price. And here you can see the parameters. So basically these are, we added 3 lags. So this is the contribution of those 3 lags. Okay. And now if you look at the residual for this model looks a lot more like a white noise compared to the previous one, right? Because here we have the auto regression component. We have yt-1 all the way to yt-10, as well as the lag values for our exogenous variable, which is temperature. So we have temperature t-1, temperature t-2, t-3. And now with that model, which has trend, seasonality, lag values, and auto regression, so this is going to look a lot better compared to our previous one. Okay, so next one is future regressors. The story is pretty much the same. So future regressors are, going back to the slide, are simply the exogenous variables that we know their future values as well as their historical value, right? And we can add them in an additive or multiplicative way to the model. And here we're going to go ahead, actually for this data set, because we knew that the temperature observations are also available into the future, so that's why we can use it as future variable as well, right? So again, we could come up with a better variable for this, but for this tutorial, the temperature can be treated both as lag exogenous variable and future, simply because we have the data historically and into the future. Okay, so, and for whatever reason, well, actually, let's look at this is the price, right? Energy price, that's the temperature. And now we can go ahead and create those future regressors, right? So again, same model, same trend, same seasonality. This should be false. Well, anyways, so they decided to turn on the daily seasonality here compared to the previous one. If you want to be super duper consistent, you better turn this off. And you're adding 10 lags for your target variable, so yt minus 1 all the way to yt minus 10. And now we are adding this temperature as a future regressor. So if you go ahead and do that, so look at that, this future regressor, you're not adding the lag values of that. So this is the variable itself. So literally we are adding one exogenous variable without considering its lag values, okay? So that's why we are thinking of it as I need to have the value of these future values into the future. Otherwise, we could not think of it as a future regressor. I know it sounded a little vague, but I just want you to pause and think about what is the difference between this future regressors and lagged regressors. So this should be pretty straightforward. Okay, now if we do that, then this is going to be the prediction. We can plot the components of the future regressors. So this is the additive future regressor, which was added to to our predictions. And this is basically the contribution of those future regressor, the temperature, to our forecast, right? And yeah, that was pretty much it. And again, if you look at the residual, this looks like a lot better compared to the model without either lag regressors or future regressors. All right, so, and the last one is going to be events and holidays. So for events and holiday, if you remember, just like Facebook Prophet, we can add events in two ways. One, it can be custom events, and the other one can be just calendar specific ones, right? So, and again, events themselves can be added in an additive way or multiplicative way to your forecasts. Okay, so here is, we are going to start with the previous. So this is the default model of NeuralProphet, and default simply means that there is no AR component, and basically there's no lag or futures regressors. So this is pretty much the same as Facebook Prophet, right? We have only trend and seasonality, the default values. So this is how the default value is going to look like. And then we can go ahead and add bunch of, for example, holidays. We can add country-specific holidays. So for example, we are adding the US calendar. This is built in just like the Facebook Prophet. It's built in NeuralProphet as well. So you can add the calendar for different countries. And so now this is how it's going to look like compared to the previous model. And of course, you can go ahead and add custom events too. So for example, there is extreme weather, and then you want to add it for specific time steps, time indices, and then you can add it. And after that, you can add this extreme weather to your events, right? So you're going to say whatever object you created, add events, the name of the variable that you just added. But just be aware, here you're doing basically the in-sample predictions. If you want to do look ahead or into the future predictions, you have to go ahead and update your future data set as well. So you need to know, for example, what is the value of these extreme weathers into the future. So when you're working with the custom calendar, so you have to be very careful that if it is something that you know for sure into the future, you can use it. Otherwise, there's not much value in doing that. Okay, so yeah, this was the events, and finally we get into the uncertainty and other stuff in the tutorial. So when it comes to uncertainty, so far whatever we have done is just point estimate. If you look at these blue lines, these are point estimates, right? So basically, let me see if I can, yeah, we cannot change the resolution, of course. We are not talking about confidence intervals here. By default, the NeuralProphet lets you to talk about or think of the conformal, the confidence intervals in two ways. The first one is using quantile regression. So basically by estimating the, let's say, 55th quantile and 95th quantile, and then basically use quantile regression to come up with those confidence intervals. Or another one is basically conformal prediction. So I will barely talk about these two in the notebook, just in a couple of minutes. But just be aware that there are, of course, more advanced ways of doing confidence intervals. But in the the NeuralProphet by default covers these two ways. Actually, I'm glad that they're at least doing conformal prediction, because this is becoming one of the most practical ways to basically do quantify the uncertainty in time series forecasting. And I will talk about conformal prediction in very detail in my next course, which is the deep quantitative trading, because we're going to create some trading strategies based on that, and you will see that it's going to outperform any other kind of confidence intervals when we're creating those signals. So that's to be discussed in the future courses. But just be aware, the NeuralProphet at least offers it, so you can create these confidence intervals using quantile regression or conformal prediction. So either of them are just fine. We can report it. And then the other thing is global modeling, right? So this is basically, for example, if you're Walmart or Amazon, you have different products at different regions. It really helps you to just work with panel time series data, right? This is multiple time series. So by default, you can use NeuralProphet to do that. And but this is not something that we cover in our course. So basically, most of the time we did univariate time series or multivariate time series for just one thing, right? But if you think that you can think of multiple time series, or you have a multiple time series task, just be aware NeuralProphet can handle that one as well. And that's also very straightforward. You just need to prepare the data set. In your data frame, you are going to have DS, Y, and another column, which is going to be, for example, the regions. And that's it. As long as you have something like this, you can run the default model, and then it will do the job for you. So you can go ahead, when you're, for example, plotting the forecast, you can plot the forecast for that specific region. Okay, so validation, reproducibility, these are pretty straightforward stuff. You're just doing the train test, validation test versus test set. So this is really straightforward. So what are the next steps? So there is also another part in the documentation which is called feature guides. I'm going to talk about some of them, and we cover some of them in the notebook, but the rest of them I leave it up to you. The ones that I think you should know is definitely, you have to know how we can do cross-validation using NeuralProphet. So this is important. We're going to look into this one. And uncertainty quantification, again, we said that there are two ways. One is quantile regression, the other one is conformal prediction. So especially, I'm super excited about this one, the conformal prediction, because that's a lot. There's a mathematical proof that the confidence intervals that are created with the conformal predictions they are valid. Valid means that it is guaranteed that when you say there's 90% confidence interval, 90% of the time in the test set, you will see that your actual value is between those intervals. So this is a big deal, especially for time series forecasting, especially if you're thinking of creating a trading signal based on those forecasting models. Then what else do we have? We have conditional seasonality, we have multiplicative versus additive seasonality. So for conditional seasonality, again, so these are custom seasonalities, right? So by default, we said that the NeuralProphet covers weekly, daily, monthly, but what if you want to do on-season, off-season, right? So for example, this is football seasons, which starts from September all the way to January. So we're going to say, okay, let's create a new variable in the data set, call it on-season. And that's basically the month of 9, 10, 11, 12, and 1. So this is whatever, again, your X is, which is DS. Just get the month should be September all the way to January, and off season is this. And then as simple as that, you're going to add it to your data frame, and then once it is in the data frame, you can just call off of that object m dot add seasonality on season, and then you can specify different Fourier orders, right? So because if you remember from seasonality, we're adding a bunch of Fourier orders to capture any kind of complex seasonal patterns, right? So when I say Fourier order 3, I'm going to add 3 of these cosine and sines together, and then try to come up with the seasonality, right? Yeah, you can play around with this, and then if you have on season, off season, when you plot it, you can see that. So for example, this is yearly seasonality, on season, off season, and etc. And of course, there are some predefined conditional seasonalities as well. So for example, you can have summer, fall, winter, spring, things like this, right? Okay. So yeah, multiplicative seasonality. This is again also pretty straightforward. You just need to, yeah, well actually we have it. This is our airline passenger data. We're going to look into this notebook just in a second. And you can simply add it by changing the mode of seasonality. If the seasonality mode is multiplicative, that's it. So we go from additive to multiplicative. Sparse auto regression. So this is where you're going to use those penalty term, deregularization, to just sparsify, if that's a correct word, sparsify your complex autoregressive components, right? And yeah, I think that's pretty much it. One other very important thing is the hyperparameter selection. I think this is your go-to page when you want to see what are the available hyperparameters when it comes to NeuralProphet. So I have summarized this in our notebook, so we're going to look into that next. So we will see that, for example, the autoregression components, what do we have? When it comes to seasonality, when it comes to trends, what are the hyperparameters that we can play around with, right? So this, now that you know the theory, hopefully from the theory lecture, playing around with these hyperparameters is pretty straightforward, and we're going to do that. All right, I think you are in a very good shape now and ready to go and jump on the notebook that I put together. So remember, there are going to be two notebooks, one for airline passenger data, which I call it a well-behaved data set, and the other one for our Apple stock price, which is the least well-behaved data sets. We're going to see in either of them how Prophet versus NeuralProphet with different tuning parameters are going to perform. Okay, so let's look into those two notebooks. All right, let's start with airline passenger data. So actually, I'm not going to go ahead and run these cells. I assume that you can run it on your local computer or Google Colab. I will basically walk you through these notebooks and then let you know, first of all, show you the results and let you know if there's any specific things that you should know when you're dealing with Prophet and NeuralProphet in Python, okay? So I assume that you can install it and then you import the airline passenger data sets, and we have to change this from month and passengers to something compatible with Prophet and NeuralProphet, which is DS and RY. So that's the first thing you should do. And here is one tricky thing, right? So make sure that you're not resetting index or you are not importing something with special, let's say, indexing headers here at the end. Just import your pure data frame and simply treat it as column names, right? So change the column name to DS and Y and then just move forward. And then your DS needs to be timestamped. So this is going to be pandas data frame timestamps. So that's how we're doing it, right? So for example, here we are changing this month to date time. And then we're going to go ahead and remove these month and passengers from the data set. Okay. So this is the hyperparameters that I was talking about just a couple of minutes ago. So these are everything you can do, and you can play around with these hyperparameters when you're working with NeuralProphet. There's some of them you have seen them before in Facebook Prophet, but the majority of them are going to be new to here. So here I'm going to talk about some of these things at a very high level, but if you're curious to what is the source code and how we can find them, specifically see what are the default values, so this is where you can find it. Go to the GitHub repository for NeuralProphet and then basically go to the main folder, NeuralProphet, and then forecaster.py. So this is the Python file. Actually, I can go ahead and open it. And then here you can see the default values of all the hyperparameters, what are the distributions, and etc., right? So I don't know, for example, if I pick any of them randomly, so let's say AR layers, right? So we can go back and search for AR layers. So as you can see, by default, it's an empty list. An empty list is referring to there's no layer, so there's going to be simply your linear version of the AR components, not the nonlinear. If you want to do, for example, the neural network, you're going to specify numbers here. So for example, I can say 20 and 30. So it's going to have two layers, two hidden layers. The first one has 20 nodes, the second one has 30. So this is basically how we can figure out what is going on with all these hyperparameters. Okay, so yeah, the number of forecasts, so probably this is going to be one of the most important one. This is your forecasting horizon. The default is 1, means that it's one step ahead, and you can go all the way to whatever number you want, right? Number of lags, so this is if you're using the AR component, this is the number of flag of AR components. Learning rate, number of epochs, and the loss function. So this is mostly related to your neural networks components, and of course the authors are using some heuristics, and you can stick to those default values, or you can play around with your own specifications if you want. Optimizers, again, the default one is Atom, and then you can change those things. Batch size, AR layer. So I think this is also very important. This is what I already told you. By default, it's an empty list, stands for linear, and you can change it to multiple different things, and then you can change it to a neural network with a bunch of hidden layers, right? So we have lag regression layer, normalizing, how you want to normalize your variable. You can do min max, you can do standardization, how do you want to handle the imputing missing observations, and yeah, a bunch of other stuff. So for example, number of change points when it comes to your trend, and then trend regularization. Remember, in the Facebook Prophet, we also said that there are two things you can change for the trend, right? Actually, let me go ahead and show you this slide. So here, so one was how many change points you can have, and the other one was this tuning parameters. It was just a knob, right? In the Facebook Prophet, we call it, these are different knobs, right? That you can think about the distribution of that hyperparameter, which basically control the magnitude of the trend, right? So if I increase or decrease that number, so this is, you can think of it as regularization of the trend. It's going to change the number of change points automatically for you, right? So yeah, you can specify a range for your change point. We have seen this before: yearly, weekly, daily, seasonality. Seasonality mode can be additive or multiplicative. Here's the same story for seasonality or regularization parameter, right? So instead of specifying, so you can, I don't know, you can tune this hub, this knob to figure out, for example, what is the magnitude of the seasonality. The AR sparsity, so basically this is going to control the sparsity of your neural network. So 0 means full sparsity, 1 means no regularization. And again, you can go with a deep neural network and regularize it back. So, and I think we talked about some of those common practices. So I think we ended up with something like this. You know, the deeper the network, typically it's going to perform in the longer term. So we talked about it in the theory lecture a lot, so make sure that you watch that video. But the idea is that, okay, so what if I want to go with so many lags and a deep network, and then we want to regularize it back, right? So that's the idea of this sparsity. Yeah, future regressor regularization, event regularization, and holiday regularization. Obviously, you can regularize any of those components, and it's a range between 0 and 1, right? So if you want to regularize it completely, or if you just want to leave them alone. Okay, so these are, I think, the hyperparameters that you should know. There are quite a few more, so if you're interested in those ones, make sure you check out this forecaster.py. All right. Okay, now let's go back and continue the journey. So I'm going to go ahead and create, let me actually show you the outline. I'm going to go ahead and create, let's close this one. So this is what I wanted to see. Create 6 different models, right? So the first one is going to be the base NeuralProphet. So this is going to be the default values of NeuralProphet. The next one is going to be the Facebook Prophet, the base version. Model 3 is going to be our Prophet, the tuned version. Model 4 is going to be our NeuralProphet without AR components, but it is also tuned. So basically, whatever M3 is, we want to replicate it with M4. So you will see how we can go from a Facebook Prophet language to NeuralProphet language. This is pretty much the same, but there's some slight changes. Actually, in the documentation, there's something there too. I can show it to you. Model number 5 is our NeuralProphet with AR component. And finally, our model number 6 is our NeuralProphet with AR components and events. So we're going to do exact same thing for our stock price prediction as well as our airline passenger data. So just remember, the airline passenger data, the frequency is monthly, and you have to specify it in the fit function when you're using NeuralProphet. And yeah, and then we're going to wrap up these notebooks by some uncertainty modeling. This is quantile regression and conformal prediction, train test evaluations, and finally comparing the models using cross-validation. Okay, so that's the plan. All right, so again, I'm going to fly through these cells here because this is pretty straightforward, and you have seen me previously talk about the details. So M1, the default NeuralProphet. We're going to fit it, make some future data frame. We're going to predict the 1 year into the future, 12 months, and we're going to keep the historical data as well because we want to visualize it. So yeah, these are the predictions. I call it forecast M1. So we're forecasting into the future. Okay. So, and right now I'm not turning off the messages or the warnings. So for the next models, I'm going to switch them off, but I just wanted you to see it at least once what is going on. So if you don't turn it off, so the logs, you will see the logs. So for example, it's going to go ahead and disable the weekly seasonality, disable the daily seasonality. Why? Because your data has monthly frequency. You will see that the batch size is 16, the epoch is default to 220. So these are dependent on the number of observations in the data and a bunch of other heuristics. Okay. All right, so now that you know what is happening behind the scene for the model M2, M3, and etc., we're going to switch it off. And I'm going to show you how to do that. Okay, so actually, this is the metric. When you fit the model with the train set, so you will see some metrics, right? So these are the metrics that by default is reported back in NeuralProphet, mean absolute error and root mean squared error. And obviously, you can go ahead and create your own version. And so as I said, it is run for 220 epochs, and this is basically after 220, these are the numbers we see, right? So for example, mean absolute error for airline passenger data was 17.3. Okay, so we have a future data set. We can forecast into the future. If I look at our forecast, which I already did forecast into the future, this is what's the output of the forecast look like, right? We have time step, we have actual, we have predictions, and we have the breakdown between different components. By default, the NeuralProphet is only including trend and seasonality. As you can see, there is no AR components. Okay. All right. So simply this means that if I add 96 and subtract 28, I will get 68. And this is the prediction for first observation, which is way off, right? Okay. So there's some subtle points here and there. So I highly encourage you to read the notebooks. I'll leave it up to you. But at the end of the day, if you install the live version of the NeuralProphet, you can use Plotly, and then with the Plotly, you can just simply work with the live version of the plot. Okay. Right now, the model is not doing a good job. So your basic NeuralProphet is missing this magnitude of seasonality. So obviously, we know that we have to add multiplicative seasonality, which we're not doing it, right? And we can visualize the components. This is the trend component. This is the yearly seasonality components. And we have seen this hundreds of times by now in the course, so you know how to interpret these things perfectly for airline passenger data, right? And we can look at the parameters as well. So for example, we know that by default it's going to be 10 change points. So these are the change points in the trend, and you can see it here as well, right? And these are your annual seasonality. So that was model 1. Model 2, exact same setup, but profit. Okay. So model 2 is the Facebook Prophet default setup. So this is how it's going to look like. And I think 1, 2, 3, 4, 5. The model decided to pick 5 change points. And of course, we need to tune this one, right? This is not necessarily the best one. But anyways, the same story here. That was model number 2. Model number 3, we're going to work with the tuned version of Prophet. This is Facebook Prophet, right? So we're going to talk about this change point prior scale, 0.05. I think if you watch the Python part of the Facebook Prophet, I'm borrowing this model from there. We specifically said why we picked these numbers. So check out that video. But basically, the idea is very simple. These are regularization parameters, and we're adding multiplicative seasonality to the Facebook Prophet model. And we are using those 3 knobs, right? 1 for trend, 1 for seasonality, and actually for holidays, there's no holiday in this one yet, right? So yeah, now with those tuned parameters, this is what the model is predicting. So just pay attention to the blue line versus the black dots, right? So this is doing an okay job, but of course we can do better. And again, these are different components. Now, model number 4, we want to map the tuned version of Facebook Prophet to tuned version of NeuralProphet, okay? So the language is pretty much the same. So for example, in Prophet, we have change point prior scale. In NeuralProphet, we have trend underscore regularization. So these are going to do the exact same thing, right? Both regularized trend changes. We have change points range. Here in the NeuralProphet, we have change points range. So the difference is only 1 S. And again, seasonality mode, this is pretty much the same. And seasonality prior scale versus seasonality regularization. Okay. And for quantile in Prophet by default, there's no quantile used. And for NeuralProphet, we just specify it to none. So again, Prophet optimizes only on point predictions. But in NeuralProphet, we said that there are 2 ways to basically quantify the uncertainty: quantile regression as well as a conformal prediction. Okay, so this is basically the mapping of M3 using NeuralProphet and this terminology. Okay, hopefully this is pretty straightforward. So yearly seasonality is on, weekly and daily is off. Seasonality mode is multiplicative, and these are the exact same numbers that we use for the tuned Facebook Prophet model. Now this is the tuned NeuralProphet model. Okay. Now with that multiplicative seasonality, as you can see, is doing a good job. So NeuralProphet and Prophet are going to perform pretty much the same. So I think we discussed it here too. So we actually looked into a lot more real world data set in the theory lecture. So this is the paper. These tables are coming from the paper. And Airline passenger the type was human. And for the human, as you can see, the performance of Prophet and NeuralProphet was pretty much the same. And that's what we're seeing. This is infinite. This is the predictions into the entire test set. And yeah, this is for 1 step ahead, 3 step ahead, and etc. Again, check out the theory lecture for more details. So that was our M4. You can look at the components, obviously. Then we have so this is the model. Look at that. All we have discussed so far, we didn't include the AR components, right? And now, just like the tutorials, I wanted to plot the residuals and see if there's any AR components screaming at us in the residuals. And that's the case, right? You know, higher errors are follow up with higher errors, lower errors are follow up with lower errors. So there is a clear AR autocorrelation component in the residuals, which has not been modeled. So we're going to go ahead and do that. So this is where Facebook Prophet is going to, NeuralProphet is going to outperform the Facebook Prophet simply because we're adding this AR component, right? So let's go ahead and do that. So we are adding this AR component with 3 lags. And as you can see, I use a default AR layer thing. So this is going to combine these lags in a linear way. If you wanted to do it in a neural network way, you could do something like this, for example, AR layers 20 and 10. So you're going to have 2 hidden layers with 20 nodes and 10 nodes, right? Yeah, so this is our model number 5. We can fit it and look at the predictions in the future values. Yeah, now look at the residuals. So this looks a lot better compared to this one. At least there's no obvious AR components in it, right? There's still some stuff there, so maybe we could use more lags, we could use more hidden layers. Obviously, we could perform better. Okay, so but now, as you can see, the predictions are better compared to what we had historically. And then finally, our model number 6, we're gonna do the NeuralProphet with AR components and events, right? So for events, this is a monthly data. I think it doesn't make any sense to add, for example, a specific country calendar like US calendar, because this is monthly data. We don't do that. But however, I was just curious, what is the impact of New Year for airline passenger data? So this is the first day of the month. We can think of it as, now, even though this is one specific day, it's going to impact the month of January, right? So we can go ahead and do that. And you have seen me doing this in the Facebook Prophet Python video as well. So this should be pretty straightforward. So we're going to add that event to our data set. So now we have a column called Event New Year. As soon as you have something like this, you can add it to the model as simple as this. Add events, the name of the calendar that you just created. Okay. So yeah, and if you do that, you need to make sure that your future data frame also has those events as well. So that's what I'm doing here. Okay, so now we can look at the performance of model 6 on the airline passenger data. We can look at basically all these decomposition between trends, seasonality, AR components, and then now events. And it seems that every first day of maybe the new year, there is fewer passengers by numbers 4. So again, the magnitude is minimal, but there's something there. Anyways, so that was how we put together 6 different models, and now it's the time to look at their performance, right? Because there are a couple of things. First, look into uncertainty modeling, and then we're looking into performance of those things doing cross-validation. Okay, so as we said earlier, the NeuralProphet support multiple ways to incorporate uncertainty quantification, right? One is quantile regression, the other one is conformal prediction. I can talk about them very briefly here, but just feel free to use, to just Google it or use ChatGPT to help you with the basic understanding of these things. But here's the Wikipedia page for quantile regression. And actually, I can explain it better if I just show you some pictures, right? So quantile regression, and then let me see if I can find a good image for you. So I want to basically show you the distribution. Yeah, this one is good, not bad. Okay, so what is linear regression? Linear regression is basically a line that goes through conditional expectations, right? If I look at the distribution at any given level of my x variable, these are the averages that I'm connecting together. Now the idea is that, why do you connect the averages? What if you connect the first, let's say 20 here in this example, 25th percentile, right? What if you connect the 75th percentile? Let me see if there's a distribution. Yeah, there you go. Okay, so this is what I was looking for, right? So at each given point, so imagine this is your y variable, this is your x variable, and I'm looking at conditional expectations. Conditional distributions, right? So at each value of x, I can look at the distribution, and for this distribution, there's an average. There's, let's say, 5% quantile, 95% quantile, 5% quantile, and think like this, right? If I go ahead and connect all these 5% quantiles, so this is going to be my basically the regression line that's connecting the percentile, 5th percentile, right? So this is going to be one thing. Another one is going to connect the 95th percentile. So these are going to act as confidence interval for you, right? So that's exactly what we are doing here. Okay, so we're saying, okay, the confidence level, for example, is 90%, and we're going to come up with our quantiles, 5% and 95%, right? And then I'm just dropping the new events because that's irrelevant. This is another thing we're doing. The new year event. So this is going back to the original data set, DS and Y. And now I just need to turn on these quantiles, right? So if we say NeuralProphet, we go with the basic model. This is our M1, right? M1, now I'm adding quantiles, right? So if I say quantiles equal to 5% and 95%, then what happens behind the scene is that NeuralProphet is going to use quantile regression, find those lines and use it as confidence intervals for you. Okay, so this is exactly what it's doing. And I'm just showing 36 steps into the future. This is 36 months into the future. And that's how it's going to look like, right? Now you have actuals, predictions, and predictions for 5% and 95%. And you can treat it as your 90% confidence interval. Okay, so that's one way. And the other one is your conformal prediction. So conformal prediction is also at least the one that I'm covering here is something called naive approach. And in the naive approach, the process is pretty straightforward. So let me see why we should go beyond this. So there are a couple of things. First of all, the validity of these predictions, the confidence intervals, is not guaranteed. So we have to come up with something that in reality, the validity of these, let's say, when we say 90% confidence, it means that in the test set, if you run this thing 100 times, it better the predictions be within those intervals 90% of the time, right? 90 out of 100. So, but that's not the case. That's not the case for this quantile regression thing. And the conformal prediction is a newer approach, which is very successful in guaranteeing those intervals, right? And another reason is that the conformal prediction is model agnostic. So hear me out here because this is very important. If you want to do quantile regression, so the quantile regression only works if your model is linear, right? But once you're doing conformal prediction is literally model agnostic. You can use random forest model and apply conformal prediction to that. You can use LSTM. As long as you have the predictions, you're done, right? You're going to do something to those y-hats, and regardless of where are those y-hats coming from, it can come from a linear regression, it can come from a LSTM, it can come from a random forest, you name it. You're done. You're going to do something to that and call that thing your conformal predictions, right? So let's see what are those steps. So this is the naive approach, right? You're going to split your time series into train period and something called calibration period, right? And then for each point in the calibration set, you're going to compute something called non-conformity scores. So this is just a fancy term. You know, you can for a simple time series task, you can simply define it as absolute error, right? So what is my error? So look at that. Black one minus the blue one. This is the error. Take the absolute value and call it non-conformity score. If this means that if that number is large, they are non-conforming, right? And then I have a bunch of these errors. Let's say we have 140 or 120 observations in the train set. This means that, and then, I don't know, let's say your validation set has 24 observations. I'm just making up some numbers. And then you're going to have 24 numbers in terms of conformity scores, right? Right. So then you can plot the distribution of that 24 numbers and look at let's say 5% and 95 percentile, and that's it. This is going to be your conformal prediction, right? So then step 3 is pick the quantile of those scores and then build your prediction intervals for the forecast. So whatever it was, right? So you have some predictions minus this Q plus that Q. So this is basically the quantile of your non-conformity scores, whatever that quantile is, okay? So this is very, very straightforward approach. And of course, the naive approach of conformal predictions, it's going to be wider because it's going to guarantee the validity of that, right? There are different methods. I think the other one that they cover, let me see, in NeuralProphet, let's go to uncertainty quantification, conformal prediction. I think they do conformalize quantile regression as well. Let's see. The method can be either naive or CQR. I think I saw it somewhere. So let me search for CQR. CQR, there you go. So yeah, it's conformalized quantile regression. So it's a combination of quantile regression and then conformal. So again, this is another approach. There are dozens of different ways when it comes to conformal prediction. This is a very deeper, broader thing for coming up for modeling on uncertainty in general, and then there's a lot more into that. So I will talk about the specific of this conformal prediction in the deep quantitative trading course. Okay, so let's go back here and try to wrap up this video because it's becoming a lengthy one. All right, so yeah, for conformal prediction, you have train set, validation set. You need to split it. So let's say the validation is 10%. The method is naive. So this is, and you can do naive or CQR. So the naive is basically this one. It's going to calculate the non-conformity scores and then just find the percentile, 90th percentile of that, and then add it and remove it from your predictions. That simple. Okay, so this is your conformal prediction kind of confidence intervals, and as you can see, it guarantees that if your quantile is 90% of the time, even in the test set, you will see these black dots within the shaded area. Okay. All right, so yeah, the next topic is train and test. So I'm gonna leave this one up to you as well because this is very straightforward. We're gonna split the data into train and test it, because so far whatever we did in the tutorial or here in this notebook was basically me showing you the performance in the train set, but how do you want to quantify it, right? Because this is time series forecasting. If you forecast into the future, there is no actual value, so there is no metric you can think of. So you have to split the data into train and test, and then look at the predictions in the test sets and compare it to the actual. This is what we're doing, right? We're splitting the data set into train and test. So here, we can think of the test set as 20%, and then train the model, fit the model using a train set, and then just basically test it on the test set, right? So, and then you can see the metrics. So for example, the performance of this model, what model are we using? I think they were using the naive, NeuralProphet with multiplicative seasonality. So this is our model. And then the performance in the test set is this, right? Mean absolute error in the test set is 18.23. Okay. Of course, we can do cross-validation. So for cross-validation, which makes more sense, we need to just keep track of some metrics that we want. So this is MAE versus RMSE, root mean squared error. And then we can keep track of the same metrics in the validation set. We can visualize this one, by the way, just like what we did in the deep learning section of the course. So we have a bunch of parameters. We put it in a dictionary. So it can be a lot more. So here for simplicity, I just added this seasonality mode. And then you need to create your folds, right? So the folds are going to be, again, this is your NeuralProphet model. Off of that, cross-validation is split the data frame. And you're going to say, I need 5 folds. And we have two concepts here, fold percentage, which is 20%, and fold overlap percentage, which is 50%. So this is very straightforward. So what is fold percentage? If it is 20%, it means that each fold will be 20% of the data. So I have a full data frame, and then 20% of data is going to be in each fold. And overlap percentage, if it is 50%, this means that each fold will overlap with the next fold by 50% of the data. And so basically here, this means that the first fold will be 20% of the data, the second fold will be 20% of the data, starting from 10% of the data, and so on. Okay. So, and then we roll this over. So this is going to be, I think in the theory lecture, we also talked about this. Yeah, this one. So this is how the NeuralProphet is doing time series cross-validation. It's holding this test set fixed, and then it's expanding window. All right, so then when you created your folds, then you can simply put it in a for loop, and then these are the folds, right? I have, for example, if I have 5 folds, I have 5 data sets here, And then I trained 5 different NeuralProphet models for them, right? With specific parameters, right? And yeah, and I want to see what is the performance in the test sets. So we're going to report that thing, right? So if you do that, so it's going to repeat these things 5 times. So this is in the first fold, second fold, third fold, fourth, and fifth. And of course, we can look at the summary statistics, right? So on average, the mean absolute error in the test set was 23, and the root mean squared error was 27. Okay, the standard deviation is relatively large here. All right, so that was the cross-validation. And the very last thing, so this is a cell that I put together to just basically compare all these models, right? And I wanted to compare this with what we already had from the PyCaret, econometric, and machine learning section of the course, right? Because this is Airline Passenger, we are wrapping up the course, and then we want to compare, we want to do a, I don't know, fair comparison between all the models that we have. So that's why I'm only predicting 12 months into the future. This is what we did with PyCaret. And actually, I have the screenshot of the PyCaret at the end of this notebook so we can do a fair comparison. So basically, again, there's nothing new here. I put everything we did before in one cell. So these are our models, M1, M2, M3, M4 with the same definition. And then we can simply look at the results, right? So the result is this. So our basic NeuralProphet model, the mean absolute percentage error. Again, this is not the best metric for time series forecasting, but for Airline Passenger, we know that there is no zero values or negative values. So this is going to be okay. So it's 6%. The base Facebook profit is also 6.6%. Again, this should be pretty much close to each other. And then the tuned version of Facebook profit, 4.4. The tuned version of NeuralProphet with no AR component, 3.2. And as soon as we add an AR component, it's going to outperform a lot better. And then if we have the events, it's going to be even better than that, right? So this is a little suspicious because our event was only just adding day 1, and this is significant. I would love to see the cross-validated value of these things, not just in the test set. And I summarized some bullet points for you here. So the default profit and NeuralProphet are okay, but not optimal. Tuning change points and seasonality. So this is what we did with M3 and M4. Of course, improve both the default values of profit and NeuralProphet. Adding AutoRegressives is a big deal. So that's why the NeuralProphet is outperforming the profit most of the time because of that lag value. Including external events here was boosting our performance, and NeuralProphet with AR components and events, basically our M6 model, achieved the best accuracy. So this basically is telling us, tuning these models, the NeuralProphet with domain expertise is going to do the best forecast performance, right? So yeah, this was the Profit versus NeuralProphet in a nutshell for Airline Passenger data. So lastly, I'm going to show you exact same notebook. This is going to be the exact same notebook, but for stock price. So where you want to find it, you have to go back to the, where is our, I think this is our, this is a GitHub. Go back to lectures and codes, miscellaneous, stock market, and then predicting stock price using profit and NeuralProphet. So I'm just going to go over it very quickly. This is our stock data set. You have seen this before in the course. So we are going to work with Apple stock price, and I think it's using 6 years of data, if I'm not mistaken. And then we want to predict the prices. And again, this setup is pretty much the same as this. So I'm going to go all the way to the end of it when we are comparing models. Okay, well, see if there's anything interesting I want to discuss here. So yeah, M1, M2. So this is the default value of profit into the future. So this is for Apple stock. Tuned Facebook profit. Then we're using with tuned NeuralProphet. Obviously for stock is not doing a good job at all. And then we have, this is the residual for the tuned NeuralProphet without AR components. And again, this is a screaming at you that stock price needs a lag value. And we know that using one lag is your naive forecaster, random walk with no drift, right? So yeah, and as soon as we do that, the residual looks a little bit better, but there's still a lot autocorrelation here that's missed by that component. So probably we need to add in more lag. And yeah, we are adding events. For events, I think we're adding US calendar. Yeah, because this is daily data. We're adding US calendars, and curious what is the impact of different holidays, right, on Apple's stock price. So we can investigate it here. And then we go to the, again, uncertainty modeling, exact same notebook, right? So this is quantile regression, and then conformalize. This is conformal prediction, and then train test evaluation, cross-validation, and comparing models. So this is what I wanted to talk about as the very last point in this entire deep forecasting course, right? So we are predicting 24 business days. So this is almost a month of data in Apple stock price. And if I scroll down, you will, so this is what you're looking for, right? And I'm borrowing some output from PyCaret as well, which use econometrics and machine learning models, right? Again, let me show you what I'm doing. So this is the, if you go back to the folder to stock market, there are two notebooks here, predicting stock price using PyCaret. So there's a full video of this on my YouTube channel. You can check it out. And now we're doing predicting stock price, exact same data set using Prophet and NeuralProphet. And this is the end of the course. We want to see, do we have a winning model, actually? So in the Prophet versus NeuralProphet world, it seems that the winner is going to be our M6, which is basically, this is mean absolute percentage error for stock price. Again, we can trust that metric too, because that's the stock price. The prices are not zero at this, and then positive, so we can trust this metric. This is a NeuralProphet model with AR components, and that's the metric. And if you use the PyCaret with the same cross-validation with the forecasting horizon, I think the forecasting horizon was 12. I need to double check. But as far as I remember, I tried to do an apple-to-apple comparison. This was the output of the PyCaret. And where was our naive forecaster? The naive forecaster was this, and it seems that, and these are not tuned model, by the way, to be fair. I mean, absolute percentage error for the naive forecaster was 4%. So none of the right off the bat econometrics and machine learning models were able to even outperform the naive forecaster. However, it seems that both, well, actually, yeah, the NeuralProphet, the Prophet also cannot outperform the naive forecaster. The NeuralProphet barely outperforms it, but when it comes to the tuned version of the NeuralProphet with AutoRegression components, it's going to outperform your naive forecaster. Okay, so finally, it seems that we have a model. By the way, LSTM was able to outperform your naive forecaster as well too. So we have a couple of models when it comes to stock price, right? So it can be LSTM, it can be, let's say now NeuralProphet, that can at least do a better job compared to your naive forecaster when it comes to stock price. And our next step is, okay, so we have these models that can perform better than naive forecaster, then what? So to answer that then what question, I needed to put together an entire separate course. So this is called Deep Quantitative Trading. And there we will say that, okay, now let's create signals based on these forecasting models, and then try to trade based on those signals. So this is a whole different kind of game, and I'm super excited about that course, and that's why we needed to do this whole journey together, at least for those of you who are interested in the finance aspect of this course, right? Of course, we can use whatever tools and techniques you learn in this course for any kind of time series forecasting. But if you're like me and if you're excited about the financial time series aspect of it, So this is going to be a very good segue to my next course. So I know I need you to have to basically bring all these tools and techniques that you learned from this course to the next one, and that would be a fun one. So until that day, which I assume it's going to take me over 5 to 6 months to put together that course, but probably after the summer I will start releasing it. Until that day, take a very good care. Make sure you review my other courses on YouTube channel as well. And once the course is ready and is published, you are all caught up and you can just join into our conversations. Okay, till the next one, take care. If you're looking to stay updated with the latest versions of the course's materials, please make sure to follow my GitHub and remember to refresh your repositories periodically. If you find yourself needing a bit more background in econometrics, machine learning, or deep learning, check out my other YouTube videos for additional insights. And for all the latest news and quick updates, don't forget to follow me on Twitter. Thanks for joining me, and let's keep learning together.